Hi everyone, this is Seep, my submission for the Stellar Hacks ZK Gaming Hackathon. Seep is a highly strategic and beloved game played by millions across South Asia. With Stellar's rapid growing presence in India, we saw a massive opportunity to bring this cultural staple completely on-chain using Sorban. However, most on-chain card games suffer from two major problems. The first is a lack of true hidden information, and the second is a terrible UX where players have to sign a wallet transaction for each move they make. We solved both. By combining UltraHawk zero knowledge proofs with a custom session wallet architecture, we have created a cryptographically secure game that feels exactly like a seamless web app. So this is the GitHub repository for the game. So you can go through this in order to read the rules. But for now, let me explain to you some of the basic ones. The first is that the total points in a deck are 100. So each card in the spade suit has the value equal to ace is 1, 2 to 10 have the face value each, jack, queen and king are 11, 12, 13 each. In addition to these, the 10 of diamonds is 6 points. So that makes a total of 100 points. The player who captures more than their opponent wins. So there are essentially 7 kinds of moves that you can make when it's your turn in order to capture more than your opponent. So this will be pretty hard to explain theoretically, but you can always come here to understand it whenever you want. For now, let's just dive right into the game and I'll explain you as we go on. The first is I'll create a session wallet and get some funding. I will connect my wallet and I will create a game. I will be copying this. Now I'll go to the in private window where I have another one opened. I will change my wallet. Although this step in localnet does not matter, the reason is because we are creating session wallets anyway, so the addresses for those will be different. So essentially, it will be player 1 not equal to player 2 anyways, but still, just for the sake of doing it, let's just do it. So you can see that we don't force player 2 into a game, both players explicitly consent to the stakes via a multi-signature initialization flow. Right here in the logs, you can see our architecture in action. Player 2 just received a partially signed transaction envelope peer-to-peer from the host via peer.js. Our client cracks open that XDR, injects player 2's signature alongside player 1's, and reconstructs the multi-sig envelope on the fly. You can also see this simulation pre-check pass test. So, uh, before we blindly submit it to the network, we execute a critical pre-flight check. We dry run a local simulation to ensure that the storage footprint and the authorization entries are perfectly calculated. This guarantees the Sorbonne VM won't wrap the transaction, ensuring a 100% success rate for game initialization. So now let me go back to this player tab. So we need to place a bid. The core mechanic of Seep involves capturing cards and building houses from a hidden hand. In a physical game, you trust your opponent that they have the card. On a public blockchain, we can do that. So right before the first card is played, look at this log. We use the Poseidon 2 hash function, which is highly optimized ZK Sorbonne highly optimized zero knowledge in ZK in Sorbonne Protocol 25 to cryptographically commit the player's initial hand to the blockchain. This permanently locks the game state, so players can swap the card later. When they eventually build a house and claim to hold a specific card, our UltraHawk CK proof validates against this exact immutable original commitment. So this is a Poseidon 2 hash. So I need to place a bid, but I can only place the bid of the card that I already have in my hand. So I will place the bid. And you can see right here, it's generating a witness, it's generating a UltraHawk proof, and the proof has been generated. Now, I placed the bid of the card 9. So either I need to make 9 from this combination and this combination, or I will need to throw this 9 on the floor. So fortunately for me, I can make a 9 right here. So if I throw 7, so 7 plus 2 is 9. So let me just do that. I'll build a house and I'll play. So a house has been built. Now let me go to this. So again, another ultra honk proof is generated, and this is essentially to show that I do actually have the card 9. Now let me go to this account. So essentially I can either throw a card or I can make a house. So let's just make a house for now. I have a queen, and this queen is worth 12 points. The reason is because this is a suit of spade. So let me just make 4 plus 8 12. So I will build a house, and there is also another one right here. So I'll merge and fix it. Essentially it will go right here, make a house of 12, and this will go here. So basically the house is fixed now. So I'll play merge plus fix and the house is fixed. Now let me go back, and again I can either build a house or I can throw something on the ground. Let me just throw something on the ground for the sake of it, just to show you that we can actually do that as well. Now let's just continue playing for a bit more and then I can show you the proof. So let me just throw this. I will go back. Another rule is we can have a maximum of two houses on the ground. So there is a house of 9 and there is a house of 12. Although I can still change this house of 9 because it's not fixed. For example, I have the 10 of diamonds in my hand, which is worth 6 points. So let me just put an ace on this so I can merge and fix. So either I can merge and fix 12, so 8, 9, 10, 11 and 12. So this will merge and fix here. But we were going to do this on the 9, right? So let's just pick it up. Okay, let me just merge and fix this right now. So this will go on this 9 and I will be able to fix it. So play merge plus fix. This house of 9 is now fixed. So let me go back to this play tab and then I can create another house. So let me just so both of these houses are, so let me just pick up this. Actually I can just direct fix it. Since I have two cards of the same suit and there is a house, I can just up this right here. So up this basically means just fixing this card on top of this pile. So I'll do that. So this is essentially the game. Now let me show you that the proof has been generated right here. Let me go to the network tab and this RPC call, and you can see that the envelope XTR is right here. So I will control copy it. I will go here and let me go to the command.txt. Hold on, not this, tx.txt. Let me go there. Now I'm going to copy and paste this right here. So essentially like this and move all this right. So I'll paste this here. Now I'll have to remove, the the co. Let me just remove these. Wait, let me just go here. The double commas right here. So I've removed all of this. Now this is the command that I need to run in order to actually check if that proof has been generated or not. So I'll run this. Sorry, this is in the root, so I'll have to go one place back and then I'll paste this and right here. So this is what has been generated right now. Let me go right about here. Right, so right about here, there we go. So I'm going to copy this. I will go there. Let me paste this right here. So we can see that this proof has been generated. The account is this. So we can see that the account is indeed this. So I'll go to this logs right here. Seed and auth host address is that and GAUI. So this is the address GAUI XQI. So this is essentially what it is. So let me show you the proof actually. So this bytes is actually the proof right here. Okay, never mind, I can't stop right there, but yeah. So this bytes is essentially the ZK proof. So huge proof right here. So this is the entire proof. So another thing that you might be wondering is, when we were playing this game, why weren't we being bombarded with wallet approval pop-ups? The reason is we engineered a session wallet architecture. When a player connects, our front end generates an ephemeral burner key pair purely for this browser session, and we fund it automatically, and it silently signs and submits every transaction in the background. So another thing is that the reason why we did this on localnet instead of public testnet was because generating a proof this complex required a massive contagious memory allocation, which currently exceeded the browser WebAssembly limits, causing out-of-memory crashes. The second is verifying a 14 kilobyte proof requires tens of millions of CPU instructions. While the math and smart contract logic are perfectly sound, this compute load currently hits the hard-capped instruction limits of the Stellar public testnet. So by architecting this on local net, we've proven our end-to-end pipeline works today. With Stellar recently introducing ZK-friendly host functions to drastically reduce compute costs, our modular architecture is future-proofed and ready to deploy on mainnet the second those network capabilities scale up. So I'd love to continue building this on mainnet, and thank you for watching this demo. Thank you. Also, ZK Seep is also deployed on the testnet right here, zkseep.versal.app. So you can access it right now, even though the ZK proofs won't work on the testnet for now. Okay, thank you.